Oh, blah, 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 blah. Probably being recorded right now, but it doesn't say that I'm being recorded yet. So I have to just sit here like an idiot until it actually says record, even though I'm pretty sure I'm being recorded right now. Yep. Stop. Oh, hey, Earth Science peeps. How you guys doing today? We are going to talk about the cause of wind. All right. And this is an essential diagram, an essential concept in what we're doing, because the cause of wind is really, when I talk about the cause of wind, what I'm really talking about is the cause of all weather. All weather can be explained in this simple diagram that we're going to do right now. All right. So you may have printed off the notes. They look something like this. All right. It's called break and wind because that's hilarious. Let's face it. Dad joke. Anyways, these are the break and wind notes because we're going to talk about wind here. And the very top, it says the cause of wind is, and underneath it, I'm going to write the cause of all weather because it really is the case. Now, last week we talked about land versus water. We talked about going to the beach, and we drew a diagram of the beach, and we said, the sun heats the earth and the earth heats the air, but the sun does not heat the earth equally. Right? The sand gets way hotter than the water on that same little isolated spot of territory there. So how is it possible that the sun is hitting it with the same amount of energy, yet they get to be totally different temperatures? Well, point of the story is the sun does heat the earth, but it doesn't heat the earth equally everywhere, right? And the most obvious example would be how the sun hits the equator and heats the equator up pretty darn well, and when the sun hits the North Pole, doesn't heat it up very well at all. All right. So the sun heats the earth and the earth heats the air, but the sun does not heat the earth equally. As a result, it not only creates wind, but it really creates all the weather events that exist. So the cause of wind is unequal heating, unequal heating of the Earth's surface. Now, I'm really lazy. And when I write Earth's surface, I do a capital E apostrophe S, and then I do SFC. I don't have a good reason as to why I do this. All right. Other than the fact that if you sound it out, Usiphus, it sounds like some sort of disease. All right. And I find that hilarious. All right. I got a bad case of the Usiphus. So anyways, Earth surface is represented by E apostrophe S SFC. Down here, I actually wrote Earth surface for you because I was able to type it out. But I've perfectly recreated this cause of wind diagram, as you can see right here, so that it's bigger for me and you guys can see a little bit better of what's happening. Okay. So this is the same diagram. We got warm area down here, cold area down here. All right. Here we have Earth's surface. Okay. So what we're going to do is talk about what happens to the air above the ground when the sun doesn't heat it equally. And as I said before, there's many reasons why one part of the surface might be warmer and another part of the surface might be colder. The land versus water is a good example. Land heats up faster and cools down faster than water does. That is a cause of unequal heating of the Earth's surface. But also another one that has come up a lot when you guys answered target questions. You guys answered and you talked a lot about albedo, or how the light is reflected off of the Earth's surface. In places that are warm areas, like the equator we talked about, all right? Warm areas tend to have a low albedo. They have a low albedo because they're absorbing a lot of the light. They're not reflecting it, so it warms it up. And if you have a low albedo, you get a warm surface area. If you have warm surface area, you have warm air above. Opposite on the other side. If you have a cool area, this is most likely a high albedo, or at least a higher albedo. Light's being reflected. It's not being absorbed. It causes the earth to be cool. And if the earth is cool, sun heats the earth heats the air. If you have cold earth, you have cool air. Okay? That's an important point right now. And that's the beginning point of the cause of all weather. Okay? Now, if I were to ask you, what happens to warm air, right? Warm air rises. Cold air sinks. Some of you may have heard this phrase, right? I know in elementary school, the elementary teachers say this a lot. They say heat rises. That's actually not true. Heat is a type of light, and light doesn't care what direction it's moving in. Whatever direction it's emitted, that's the direction it's going to go. So heat doesn't rise. Air that has a lot of heat, warm air, will rise. And warm air rises because it's less dense. Okay, it comes back to that property of density, which is really the most important in earth science. Really, cause of all weather, cause of all plate tectonics can come back to density. So that's a really important concept. So warm air rises, not because it wants to, not because heat rises. Warm air rises because it's less dense than the cold air, and the cold air actually pushes it up out of the way. Okay, so we're going to start with the cold air side of this diagram. We're going to start over here. So it helps to have a blue colored pencil or marker or pen. You don't need it, but that's what's happening. So cold air, right, is cold because it's literally above a cool surface. And if it's above a cool surface, right, it's going to lose energy to that cool surface. Okay, and as a result, there'll be less infrared, there'll be less energy in those air molecules, which means they're going to slow down in their motion. They're going to get closer together. They're going to get more dense. And that means they're going to be heavier for the volume that they take up. As a result, they sink. All right. Cold air sinks because it's more dense. Okay. So cold air sinks because it's more dense. Okay. Cold air sinks because it's more dense. All right. Now that cold air sinks, but it doesn't just stop when it hits the Earth's surface, right? It doesn't stop there. If I take a bucket of water and I pour that water out on the ground, when the water hits the ground, it doesn't just stop when it hits the ground. It splashes outward. And that's what this cold air is like. This cold air hits the ground and it splashes outward. In one of the directions it moves, in this case, is to my left or towards the warm area. It might also go in this direction, might also go towards you or into the paper, right? If you can think about this three-dimensionally, all right? But it splashes outward, okay? Well, this cold air comes pushing through this way, and it hits this warm air. Warm air is less dense, right? That warm air gets pushed out of the way. As a result, the warm air, God dang it, we're going to use pink. The warm air goes up because warm air rises, right? Warm air rises because it's getting pushed up by that more dense cold air that just came swooping in after it got splashed outward like that. So warm air rises because it's less dense than cold air, and the cold air pushes it up. So warm air rises because it's less dense than the cold air. Okay. Warm air rises because it's less dense. All right. Now, we have a lateral motion of air right here. That horizontal movement of air, what is sometimes referred to as advection, but you don't need to know that term. That horizontal movement of air is what we call wind. Okay. Wind. Okay. So what created the wind? Unequal heating of the Earth's surface, right? The wind is caused by the cold air sinking, smacking into the Earth's surface, splashing outward, and then pushing that warm air up, right? Now, when that warm air hits the top of the troposphere, you guys might remember from the poster project, when you leave the troposphere and you enter into the next layer, the stratosphere gets warmer as you go up. Warm air only rises when it's warmer than the surrounding air. If the temperature is the same, that warm air is not any less dense than the surrounding air. It's not going to rise anymore. So warm air only rises if it's warmer than the surrounding air. So at some point, it's going to stop at the top of the troposphere. And kind of like what happened with the cold air over here splashing out, it's going to be upside down, but it's the same process. That warm air hits the top and splashes. We're going to use orange now. Splashes outward like this, okay? Creating another horizontal motion of air. This is what we refer to as the jet stream. Literally a current of air in the upper part of the ocean, of the atmosphere, right? It's very similar to an ocean current. All right, so we're going to stop here, mostly so I can sharpen some colored pencils. But this is part one of the cause of wind. We are going to do a part two coming up right now. You know, that dramatic pause that I just did, I should have waited again till I was more prepared to stop the recording. One of these days, I'm going to get that. I'm going to get it. I don't know if it's going to happen now. Hey, real fast. There's my dog. All right. A couple nights ago, he got skunked. Yep. We've been stuck in a house with a skunked dog. And you know what? I wouldn't have it any other way.